Hello everyone, welcome to today's session. Today's topic is confusion matrix. Now let's move on and look at what exactly a confusion matrix is. Confusion matrix is the last topic for descriptive statistics. Read after this. I'll be running a short demo where I'll be showing you how you can calculate mean, median, mode, and standard deviation variance and all of those values by using R. So let's talk about the confusion matrix. What is the confusion matrix? Now don't get confused. This is not a complex topic. Confusion matrix is a matrix that is often used to describe the performance of a model, and this is specially used for classification model or a classifier. And what it does? It will calculate the accuracy or it will calculate the performance of your classifier by comparing your actual results and your predicted results. So this is what it looks like, to positive, to negative, and all of that. Now this is a little confusing. I'll get back to what exactly true positive, true negative, and all of this stands for. For now, let's look at an example and let's try and understand what exactly confusion matrix is. So guys, have made sure that I put examples after each and every topic because it's important for you to understand the practical part of statistics. Statistics has literally nothing to do with theory. You need to understand how calculations are done in statistics. So here, what I have done is, now let's look at a small use case. Let's consider that you have given data about 165 patients, out of which 105 patients have a disease and a remaining 50 patients don't have a disease. So what you are going to do is you will build a classifier that predicts by using these 165 observations. You will feed all of these 165 observations to your classifier and it will predict the output every time a new patient detail is fed to the classifier. Now out of these 165 cases, let's say that the classifier predicts yes 110 and no 55 times. So yes basically stands for yes, the person has a disease, and no for no, the person does not have a disease. That's pretty self-explanatory. But it predicted that a 110 times patient has a disease and 55 times that no, the patient doesn't have a disease. However, in reality, only 105 patients in the sample have a disease and 60 patients who do not have the disease. So, how do you calculate the accuracy of your model? You basically build the confusion matrix. This is how the matrix looks like, and it generally denotes the total number of observation that you have, which is 165 in our case. Actually denotes the actual use in the data set, and predicted denotes the predicted value by the classifier. So the actual value is no here and the predicted value is no here. So your classifier was correctly able to classify 50 cases as no since both of these are no. So 50 it was correctly able to classify, but 10 out of these cases is incorrectly classified, meaning that your actual value here is no, but your classifier predicted it as yes. That's why this 10 over here. Similarly, it wrongly predicted that 5 patients who do not have disease, whereas they actually did have disease, and it correctly predicted 100 patients which have the disease. I know this is a little bit confusing, but if you look at these value no 50 meaning that is correctly predicted 50 values, and no yes means that it wrongly predicted yes for the value it was supposed to predicted no. Now what exactly is the true positive, true negative, and all of that? I'll tell you what exactly it is. So, true positive are the cases in which we predicted a yes and they do not actually have the disease. So, it is generally this value already predicted a yes here, even though they did not have the disease. So, we have 10 true positives. Similarly, true negative is we predicted no and they don't have the disease, meaning that this is correct. False positive can be predicted yes, but they do not actually have the disease, and this is also known as type 1 error. False negative is what we predicted no, but they actually do not have the disease. So, guys, false negative and true negative are correct classifications. So, this was confusion matrix, and I hope this concept is clear. So guys, that was the entire descriptive module, and now we will discuss about probability. So before we understand what exactly probability is, let me clear out a very common misconception. People often used to ask me this question: what is the relationship between statistics and probability? So probability and statistics are related fields. Probability is a mathematical method used for statistical analysis. Therefore, we can say that probability and statistics are interconnected branches of mathematics that deal with analyzing the relative frequency of events. So, they are very interconnected fields, and probability makes use of statistics and statistics makes use of probability. They are very interconnected fields. So, that is the relationship between statistics and probability. Now, let's understand what exactly is probability. So, probability is the measures of how likely an event will occur. To be more precise, it is the ratio of desired outcome to the total outcomes. Now, the probability of all outcomes always sums up to 1. The probability will always sum up to 1 probability, cannot go beyond 1. So, either your probability can be 0 or it can be 1, or it can be the form of decimals like 0.5 or 0.55, or it can be in the form of 0.5, 0.7, 0.9, but it's valuable to always stay between the range of 0 and 1. The famous example of probability is rolling a dice example. So, when you roll a dice, you get 6 possible outcomes. You get 1, 2, 3, 4, and 5. 6 faces of a dice. Now, each possibility only has one outcome. So, what is probability of rolling a dice? You will get 3. The probability is 1 by 6, right? Because there is only one face which has a number 3 on it. Out of 6 faces, there is only one face which has the number 3. So, the probability of getting 3 when you roll a dice is 1 by 6. Similarly, if you want to find the probability of getting a number 5 again, the probability is going to be 1 by 6. So, all of this will sum up to 1. So, guys, this is exactly what probability is. It's very simple concept. We will learn it in 8th standard onwards. Now, let's understand the different terminologies that are related to probability. Now, the 3 terminologies that you often come across when we talk about probability. We have something known as the random experiment. It's basically an experiment or a process for which the outcome cannot be predicted with certainty. That's why you use probability. You are going to use probability in order to predict the outcome with some sort of certainty. Sample space is the entire possible set of outcomes of a random experiment. An event is one or more outcomes of an experiment. So, if you consider the example of rolling a dice, Now let's say that you want to find out the probability of getting A to when you roll the dice. So finding this probability is a random experiment. This sample space is generally your entire possibility. So 1, 2, 3, 4, 5, 6 faces are there, and out of that you need to find the probability of getting a 2. So all the possible outcomes will generally represent your sample space. So 1 to 6 are your possible outcomes that represent sample space. Now event is one or more outcomes of an experiment. So in this case, my event is to get a 2 when I roll a dice. So my event is the probability of getting a 2 when I roll a dice. So guys, this is generally what random experiment, sample space and event really mean. Now let's discuss the different types of events. There are two types of events that you should know about: disjoint and non-joint events. Disjoint events, these are events that do not have any common outcome. For example, if you draw a single card from a deck of cards, it cannot be king and a queen. It can either be queen or can be king. Now, non-disjoint events are events that have common outcomes. For example, a student can get 100 marks in statistics and 100 marks in probability, and also the outcome of a ball delivered can be a no ball and it can be a 6. So this is non-disjoint events are. These are very simple to understand. Now let's move on and look at the different types of probability distributions. I'll be discussing the three main probability distributions functions. I'll be talking about probability density function, normal distribution, and central limit theorem. Probability density function, also known as PDF, is concerned with the relative likelihood for a continuous random variable to take on a given value. So the PDF gives the probability of a variable that lies between the range A and B. So generally what you are trying to do is you are going to try and find the probability of a continuous random variable over a specified range. Now this graph denotes the PDF of a continuous variable. Now this graph is also known as the bell curve. It's famously called the bell curve because of its shape, and there are three important properties that you have to know about a probability density function. Now the graph of a PDF will be continuous over a range. This is because you are finding the probability that a continuous variable lies between the range A and B. The second property is that the area bounded by the curve of a density function and the x-axis is equal to 1, and the area below the curve is equal to 1 because it denotes probability. Again, the probability cannot arrange more than 1. It has to be between 0 and 1. Property number 3 is that the probability that our random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. So what this means is what the probability value is denoted by the area of the graph. So whatever value that you can get here, which generally one is the probability that is random variable, will lie between the range A and B. So I hope if you have understood the probability density function. It is basically the probability of finding the value of a continuous random variable between the range A and range B. Now let's look at our next distribution, which is a normal distribution. Now normal distribution, which is also known as the Gaussian distribution, is a probability distribution that denotes the symmetric property of the mean right meaning that the idea behind this function is that the data near the mean occur more frequently than the data away from the mean. So what it means to say that the data around the mean represent the entire data set. So if you just take a sample of data around the mean, it can represent the entire data set. Now similar to the probability density function, the normal distribution appear as a bell curve. Now when it comes to normal distribution, there are two important factors. We have the mean of the population and the standard deviation. So the mean and the graph determines the location of a center of a graph, and the standard deviation determines the height of the graph. So if the standard deviation is large, the curve is going to look something like this. It will be short and wide, and if standard deviation is small, the curve is tall and narrow. So this was it about normal distribution. Now let's look at the central limit theorem. Now the central limit theorem states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. So that's a little confusing. Let me break it down for you to in a simple terms. If we had a large population and we divided it into many samples, then the mean of all the samples from the population will be almost equal to the mean of the entire population, meaning that each of the samples is normally distributed. So if you compare the mean of each of the samples, it will almost be equal to the mean of the population. So this graph generally shows a clearer understanding of a central limit theorem. You can see each sample here, and the mean of each sample is almost going the same line. So this is exactly what the central limit theorem states. Now the accuracy of the resemblance to the normal distribution depends on two main factors. So the first of the number of sample points that you consider, and second is the shape of the understanding population. Now the shape obviously depend on a standard deviation and the mean of the sample. So guys, the central limit theorem basically states that each sample will be normally distributed in such a way that the mean of each sample will coincide with the mean of the actual population. In short terms, that's what the central limit theorem states, and this holds true only for a large dataset. Mostly for a small dataset, and there are more deviations when compared to a large dataset, is because of the scaling factor. The small deviation in a small dataset will change the value very drastically, but in large dataset, a small deviation will not matter at all. Now let's move on and look at our next topic, which is the different types of probability. Now this is an important topic because most of your problems can be solved by understanding which type of probability should I use to solve this problem. So we have three important types of probability. We have marginal, joint and conditional probability. So let's discuss each of this. Now the probability of an event occurring unconditional on any other events is known as marginal probability or unconditional probability. So let's say that you want to find the probability that a card drawn is a heart. So if you want to find the probability that a card drawn is a heart, the probability is 13 by 52. Since there are 52 cards in a deck and there are 13 hearts in a deck of cards and there are 52 cards of a total deck. So your marginal probability will be 13 by 52. That's about the marginal probability. Now let's understand What is joint probability? Now, joint probability is a measure of two events happening at the same time. Let's say that the two events are A and B. So, the probability of event A and B occurring is the intersection of A and B. So, for example, if you want here and you want to find out the probability that a card is a 4 and a red, that would be a joint probability because you are finding a card that is 4 and the card has to be red in color. So for the answer, this will be 2 by 52 because we have half in heart and we have half and diamonds. So both of these are red and color, therefore our probability is 2 by 52, and if you further down it is 1 by 26. So this is what joint probability is all about. Moving on, let's look at what exactly conditional probability is. So if the probability of an event or an outcome is based on the occurrence of a previous event or an outcome, then you call it a conditional probability. So the conditional probability of an event B is the probability that the event will occur given that the event A has already occurred. If A and B both are dependent events, then the expression for conditional probability is given by this. Now this first term on the left hand side, which is P B of A, is generally the probability of event B occurring given that event A has already occurred. So like I said, if A and B are dependent events, then this is the expression. But if A and B are independent events, then the expression for conditional probability is like this. So guys, P of A and P of B is obviously the probability of A and probability B. Now let's move on. Now in order to understand conditional probability, joint probability and marginal probability, let's look at a small use case. Now basically we are going to take a data set which examines the salary package and training undergone by my candidates. Now there are 60 candidates without training and 45 candidates which have enrolled for tech tutorial trainings. Now the task here is you have to access the training with a salary package. Let's look at this in a little more depth. So in total we have 105 candidates, out of which 60 of them have not enrolled tech tutorial training and 45 of them have enrolled of a training. This is a small survey that was conducted and this is the rating of the package or salary that they got. So if you read through the data, you can understand. There were 5 candidates without tech tutorial training who got a very poor salary package. Similarly, there are 30 candidates with tech tutorial training who got a good package. So guys, basically you are comparing the salary package of a person depending or whether or not they have enrolled for tech tutorial training. This is our data set. Now let's look at our problem statement and find the probability that a candidate has undergone tech tutorial training. Quite simple. Which type of probability is this? This is marginal probability. So the probability that a candidate has undergone tech tutorial training is obviously 45 divided by 105. Since 45 is the number of candidates with tech tutorial training and 105 is the total number of candidates, so you get a value of approximately 0.42. That's the probability of a candidate that has undergone tech tutorial training. The next question finds the probability that a candidate has attended tech tutorials training and also has a good package. Now this is obviously a joint probability problem. So how do you calculate this? Now since our table is quite formatted, we can directly find the people who have gotten a good package along with tech tutorial training are 30. So out of 105 people, 30 people have training and a good package. They specifically ask for people with training, remember that. The question is to find the probability that a candidate has attended tech tutorial training and also has a good package. We need to consider two factors, a candidate who attended the training and who has a good package. So clearly that number is 30. 30 divided by total number of candidates, which is 105. So here you get the answer clearly. Next, we have found the probability that a candidate has a good package given that he has not undergone training. Now this is conditional probability because here you are finding a condition. You are saying that you want to find the probability of a candidate who has a good package given that he has not undergone any training. The condition is that he has not undergone any training, so the number of people who have not undergone training are 60 and out of 5 of them have got a good package. That's why this is 5 by 60 and not 5 by 105 because here they have clearly mentioned has a good package given that he has not undergone training. So you have to only consider people who have not undergone training. So any 5 people who have not undergone training have gotten a good package. So 5 divided by 60, you get a probability of around 0.08, which is pretty low. So this was all about the different types of probability. So guys, I hope this use case is helpful for you and is clear all your doubts. And if you have still any doubt, you can write down in our comment section. Thank you so much for watching.